Alright, so this lecture is going to focus on spatial grounding. What we're talking about here is that GIS and geospatial science is a very specific field. So we want to take a step back and we want to look at the bigger picture of all of this. And we know that to study physical geography together, we're all going to need to be starting with the same type of vocabulary. So that's what we're going to focus on today. Alright, so to start this instruction period out, what I'm going to want you to do is I'm going to want you to take a few minutes on your own and draw a map of the A&M Corpus Christi campus. For those of you that are tuning into this that aren't A&M students, go ahead and draw a map from your home to your place of work or from your home to a local grocery store. All right, and when you're making these maps, I want you to focus on drawing it from memory. All right, I don't want you to think about um, specifically what does another map look like, specifically what are all the infinite small details. I want you to take the things that are in the front of your mind and draw the map this way. All right, and when you're done drawing with that, all right, go ahead and keep it in front of you, and we are going to come back to it a few times throughout this lecture. All right, and because this lecture is being recorded, we're going to go ahead and go forward now, so if you need time still to draw, just pause the lecture and hit play when you're ready. So let's first look at our priorities in geography. These can be considered fundamental concepts of spatial analysis, the level or ways at which we study geographic phenomena. Spatial analysis includes any of the formal techniques which study entities using their topological, geometric, or geographic properties. First, we're going to take a look at scale. Scale can be best thought of as a partitioning of space and or time wherein different physical and natural events, as well as political, economic, and social problems, play out. Traditionally, geographic study was somewhat compartmentalized in a work focused at different scales, so that the political geographer focuses on the behavior of national states, or national voting patterns, for instance, while the urban geographer focused on urban patterns and processes. In recent decades, there's been more and more attention by geographers to the way in which patterns and processes act at one scale and then shape patterns, processes, conditions, and events at another scale. Temporal scale can focus on effects over time and is fundamentally important when using spatial analysis to assess things like weather or climate. We can observe weather today and clearly state what is happening at this instance, but as we zoom out, but we zoom out as we want to predict what will likely happen over the next few days or even years. The more short-term observations we collect, the stronger our models for long-term temporal events are. Another example is looking at tidal observation networks, like Tikkun. The moment those stations are set up, we begin collecting data, and we know exactly what's happening at those stations exactly at that moment. But we require 20 years of continuous data before we can use the stations to predict and model tidal influences across the Gulf Coast. So now that we've looked at scale, let's get into the actual fundamental concepts of spatial analysis, starting with space. Space can be considered a physical or geographical location. It can be measured in absolute, relative, and cognitive terms. Absolute space is best seen as an independent variable. Absolute space will retain its state or attributes regardless of the existence of the things around it. Consider a classroom full of students. The room is a classroom because we intend to conduct instruction here. But what happens if I remove all of the students from the room? Is it still a classroom? Yes, it is. Regardless of the room having students in it, the room is still a classroom because it's intended to conduct instruction. So remember that absolute space is space that has an existence independent of the existence of the material things and relations to it. Think of this space as a permanent, boundless container. Maps focus on what is physically in front of us, not the individual attributes. Relative space depends on the events and relationships associated with it. Think of a bus route. The street is the absolute space because it doesn't depend on a bus route. But the bus route does depend on the bus stop along the street in order for it to be a bus route. We even have the ability to change relative space and create new relationships. Remember that this space is understood through events and relationships such as the connectivity between locations. So pull your maps back out and be observing them as you're listening to this. Cognitive space delves into the concept of perception. This is where your maps from earlier come into play. Now that you're looking at them, what did you focus on when you were producing your map? Did you think of the actual route you take to get from point A to point B? Is your map focused a bit like a blueprint, laid out, grid-based pattern? This is the way the roads and the networks exist in reality. Or did you focus on landmarks that remind you of where to turn? Go down this street, turn left at the gas station, drive a little bit further. There's a Starbucks here, take a right. And then your job is just a couple lights down on the right. Think of it that way. So if you made your map alongside someone else, go ahead and take a look at their map now and see how it's different from yours and how it's similar. If you didn't make your map next to someone, go ahead and take a look at an actual map. Pull out Google Maps and put in the routes between the 2 points that you were focusing on and see what's different. What did you miss? What things didn't come to you in your mind? Knowing that other people may experience the same space differently helps you understand that they will see the world differently as well. Understanding cognitive space and how people see things definitely pushes cartographers, mapmakers, to ensure their spatial products minimize bias and promote reality and not perception. So now let's talk about location. Location is the role of space. It provides a reference to locate a particular place or position, and location can be measured in absolute and relative terms. Here, we're looking at absolute location. By using latitude and longitude from a Mercator chart, we are defining a location on this coordinate system that is not dependent on what is at that location or what is around it. Whether a location is the middle of the ocean or the top of the Eiffel Tower, those coordinates will always represent the same location in this coordinate system. Relative location is the location of place relative to other information or landmarks, and it can be measured. Geographers often define relative location using information about site and situation. Site focuses on physical attributes of a location. What is actually there? Am I looking at a forest, mountain range, maybe even an artificial oyster reef? Just tell me what is the extent of what we're looking at and what could actually be there. Situation focuses on a location in relation to another location. What am I near? Should I move to Kansas if I want to be a marine biologist? Probably not, because there probably aren't any jobs for that field nearby. So here, we can see by the red bounding box that we are defining our site. I'm not focused on where it is compared to something, I just want to define the extent of the location I am observing. But we still need to define the situation. Our extents don't tell us what we are looking for. Inside our bounding box, we're actually within Wakulla County, Florida. We know that Wakulla County, Florida is within the Florida Panhandle. We know that we are near one of the largest freshwater springs in the world, and that it's above the Floridian Aquifer. We also know specifically that we're near a wastewater treatment plant that is also near homes who use the aquifer as a source of fresh water. Now that we understand the situation and our site for our relative location, we are able to consider what we could actually be looking for. What is it that we're trying to perceive? Sure, there's a lot more information we could pull here, We could define in our situation exactly how many cars are in the area, how much of the area is covered in streets, what is the percentage of land to water in our area. But we didn't define that. What we did define tells us that we're looking at a wastewater treatment plant near homes over one of the largest freshwater springs in the world. So a likely concern that we could be having here is that we want to ensure that our site and the situation related to it isn't causing pollution to this freshwater supply and that the homes near it are still receiving clean, fresh water. Relative location could seem like a big can of worms, but to narrow it down to something manageable, remember that situation is relative location, as relative location tends to refer to factors that affect the quality of life, opportunities, limitations at a given site. Lastly, let's discuss distance. Distance refers to the amount of space between two things or places. Distance can be measured in absolute, relative, and cognitive terms. When thinking of absolute distance, think of distance between cities as a simple example. The absolute distance refers to the physical units of measure between the two objects, like cities. We tend to use units of measurement that are meaningful and appropriate, such as feet or miles. Or, say you're in the United Kingdom, you're probably going to be focusing on things like kilometers and things like that, imperial, non-imperial units. Relative distance refers to the non-spatial cost of getting between one place and another. If any of you have been to Houston, you probably measured distance by how long it takes to get from one place to another. Because of constant traffic and construction, knowing how many miles you are from something is often meaningless. The cost to get somewhere is time, not miles. So remember that relative distance is a measurement of distance that includes the cost of overcoming the absolute distance between two places. And it can be defined in terms of time, effort, or cost. So take your maps out again. So again, we see perception as a measure in cognitive distance. If you're from Texas, taking a day trip from San Antonio may not seem like that big of a deal. It's only 2 hours away after all. So what if you're from, let's go with New Jersey. My wife is from New Jersey, but when I talk about just going up to San Antonio for a meeting, she wonders if I'll be getting a hotel. Should we make a long weekend out of the event? Am I going to pack enough clothes? She'll even warrant it far enough to need to know that I made it there safely. Her perception of far is much different than mine. But then again, her perception of the world was limited to New Jersey growing up, which is actually smaller than Houston. So to define it, cognitive distance is a measurement of distance which depends on an individual's perception about the amount of spatial interactions between 2 points. When you're looking at year maps, what are the things that you focused on? Say we're looking at the A&M Corpus Christi campus. Things like the Conrad Blucher Institute or the Hart Research Institute could be way off in the boonies on your map. They might not even made it onto the island as far as you're concerned. Your world's probably focused around the heart of the campus. The parking garage is probably the farthest thing away. Or if you're in a spatial science, not a spatial science, but another research science lab, you could have been focusing over by the church where the modular buildings are. Say you're taking a look at your drive to work. If you tried to use a relative landmark in order to define where things were on your way, saying gas stations, coffee shops, whatnot, you were focusing on the spatial interactions between point A and point B, opposed to the grid-like pattern of I drive due east this far, take a left, and yada yada yada. So lastly, why do we need to concern ourselves with these fundamental concepts of spatial analysis? It's because geography and GIS is concerned with the examination of space, and these concepts give us the means to accurately discuss them. That is going to be the purpose of this course, is to get the conversation going. As we go forward through the rest of our lectures, we're going to be trying to take our worlds around us, the fields that we're studying, if they're not GIS specifically, and identify and discuss what is spatial about them. How does GIS or geography promote what I'm doing? And lastly, remember that everything is related to everything else, but near things are more related than far things. All right, that was our quick lecture on spatial grounding. I look forward to seeing you all at our next lecture.